morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are talking about binary operations again. This is part 3, so let's get to it, shall we? We'll check back on Vampire Weekend towards the end of our adventure. All right, so last time we were together, we talked about the associative law. This is in the last video that you have seen, but I'm just setting up to talk about something. And then we did some examples where we determined whether particular binary operations were associative or not. And in order to do that, we had to show that A star B was equal to A star B star C with the parentheses and whatnot. I will not belabor that again. See right here, A star, that's not equal. A star B star C with parentheses here was not equal, so this was not an associative. A star B star C was equal to A star B star C with the different parentheses. We ended up with the same thing. So they were associative. And that is just to lead into this. When we have a multiplication and addition of real numbers, we can do this with we don't have to group them. It means the same thing regardless. We just take it for granted that it's associative. And this is true generally for associative functions. And if star is associative, then there is no ambiguity if we just write it like this rather than using parentheses. Furthermore, just like with the multiplication symbol, the operation like this we can write as a to the n, and in fact if we have a to the m star a to the n, it's equal to a to the m plus n, and furthermore a to the m to the n can be written as a to the mn, just like we are used to. Okay, so just wanted to specify that. And now we're going to talk about the commutative property, and you'll recognize the notation here. We say that a binary operation star on a set S is said to be commutative if A star B equals B star A for all A and B, which is an element of said set S. So all that means is whatever the operation star is, if I perform it with A as the first and then B, and then I perform it with B as the first part and then A, and they end in the same result, then we can say that that binary operation is commutative, okay? And we know that multiplication and addition are commutative properties on the real number system, whereas subtraction and division are not. If we can find that a binary operation star is both associative and commutative, then we can include this rule right here as an index law. And there's a nice little example here that we're going to do, and then there's just one more example after that. If the binary operation star is both associative and commutative on a set S, show that AB squared is equal to A squared B squared. So let's take a look at this. So if I do have A, B, the quantity squared, that is equivalent to A star B times A star B, whatever that operation is. Not times, A star B star A star B, because we don't know what the operation, binary operation is just yet. And then I can say by the associative property that this is true. A star B star A star B. So all I've done is drop these parentheses and move them around a bit, and this is true by the associative property. I'll just put assoc there. And then I'm going to do this, A star B star B. And what did I do there? Well, I just used the commutative property to do that. And then I'm going to use associative again, moving the parentheses around. and so that's associative. And by what we just discussed on the previous page, I can write a star a as a squared, and I can write b star b as b squared. So that's just a short little proof there about the commutative law. And not the commutative law, just using these indexes, but we use the commutative. And we can do all this because we can say biassociative, bicommutative, and bisociative because we have stated that the binary operation star is both associative and commutative on a set S. So that's why we were able to use these as justifications. Okay, and then this will be our last example here. Determine whether the following operations on the real numbers, set of real numbers, are commutative. Okay, so we know here that a star b is equal to 2a plus b, but what we're trying to show is that a star b is equivalent to b star a. Okay, and we know this. Okay, so I am going to rewrite a star b is equal to 2a plus b, right? And then if I have b star a, you can't get hung up in what's b and a here. This a and b here stands for the first element and then the second element, or whatever it is that you're going to use. So if I write b star a, that's going to be equal to 2b plus a. Because in this binary operation, the first thing is multiplied by 2, and then the second thing is just a tag on. Well, b is first, it's going to be the one multiplied by 2, and then a is going to be added on to that. So let's for both of these, we're going to let a equal 3, and, oops, why is that not working? Let me erase that, please. I don't know why it's not working. I'll have to do that. Let's do this. Let a equal 3 and b equal 2. Okay, so right here, a is 3, so 3 star 2 would be equal to 2 times 3 plus 2, which is equal to 8. And that's for a star b. So for b star a, this would turn into 2 star 3, because again, b is equal to 2, so I replace b with 2, and a is equal to 3, so I replace a with 3. So that would be equal to 2 times 2 plus 3, which is equal to 7. And I'm pretty sure that a is not equal to 7, which then implies that a star b is not equivalent, is not equal to b star a, which then implies that the operation is not commutative. It is not commutative. Okay. And let's try out b. Again, we're trying to show that a star b is equal to b star a, and if that's true, then the operation is commutative. And so for a star b, that would equal 3 to the a plus b, and then for b star a, that would be equal to 3 to the b plus a. And hopefully you see right away that this is indeed commutative. And we can go ahead and just say, let's let, why change anything? A equal 3 and B equal 2. And let's see what happens. So then 3 star 2 would be equal to 3 to the 3 plus 2, which is 3 to the 5th power. And then B star A would be 2 star 3 would be equal 3 to the 2 plus 3, which is 3 to the 5th power, which implies that A star B is equal to B star A, which implies that the operation is commutative. And I'll abbreviate that. The other way we could go here is B star A, we actually did this right here. Let me just rewrite it. B star A is equal to 3 to the B plus A, which is equal to 3 to the A plus B, because the addition is commutative, yes. Addition on the real number system is commutative. Well, 3 to the A plus B, boys and girls, is equal to that, which is equal to A star B. So we have a progression here where B star A is equal to A star B. So there you could also say that that's another way to say that this operation is indeed commutative, okay, without using any numbers. All right, so that's all I have to say about that. Hope you enjoyed it. We are going to sign out with a little Vampire Weekend. Hope you're enjoying it. And with that, I am going to say that I am